So here we go. Now we're going to talk a little bit about the atom. I'm not quite sure what you guys know, but I want to make sure you have some good foundation for it. We're going to start setting the stage for the periodic table, and we'll get into that later. But right now, let's go ahead and get some basic notes on this, and I would definitely recommend you write them down. Notebook's a great place. So, real quick, what is an atom? Well, an atom makes up all things. Okay? Everything around you is made up of atoms. Okay? All sorts of different types of atoms. Now, atoms are the basic unit of matter. If it exists, it's composed of atoms. Okay? One thing to keep in mind. Now, atoms themselves are made up of pieces. We call those subatomic particles. Sub means below. So these are things that are below the atom. Okay? They make it up. Now, keep in mind, these are things that make up. They're smaller than the atom themselves. We can barely see fuzzy outlines of atoms. Okay? There's no way we can see the things that make them up, but we actually have ways to find out that they are there. Okay? So with that, let me move myself. Let's go ahead and fill this out. You're going to see a chart like this later. And subatomic particles, there are 3 subatomic particles. And you should be familiar with them. I'm going to move myself over here. You should have heard probably some of them, and we'll go from there. Now, one of the first ones you heard, where's my pen? Oops. There we go. One of the first ones you've probably heard about is the proton. Now, proton, what are some other ones? Well, you've heard of a proton. You've hopefully heard of an electron. And you may or may not have heard of, which one? That's right, the neutron. Okay, so those are the particles themselves, proton, electron, or neutron. Now, let's go ahead and figure some things out. If we look at the symbol of the proton, you're going to see it 2 ways. This is a lowercase p, or you'll see it as a p+. Now, the electron is a lowercase e, or you'll see it as an E-. And for neutron, you can probably figure that out, lowercase n. Why lowercase? It sounds good. Actually, it can deal with the fact that we have some elements that have those for symbols. Now, the charge. If we look at a proton, pro actually means positive. Okay, if you're pro something, that means you're for it. So a proton has a positive charge. Electron, if you look at the symbol, kind of gives it away. It's a negative. Neutron, the root of neutron is neutral. So we say it has 0 charge. Now, if you know anything about the atom, you actually know about where they're found inside an atom. If not, let's go this way. A proton is found in the very center of the atom. The center of the atom is called the nucleus. Okay. Now, the nucleus actually contains one other thing besides the proton. The neutron also contains the nucleus. The nucleus contains the neutrons. There we go. So where does that put the electrons? Well, oddly enough, the electrons are found in the electron clouds. Sometimes you're going to hear these referred to as rings. And when we get further in, we're going to give them another name as we apply it, called periods. Okay. Those are the 3 things there. Now, because these things make up atoms, and atoms are the foundation of all matter is made up of. Well, matter has mass. That means atoms have mass. That means the things that make up the atoms have to have mass too. I'm not going to go into the specifics behind what they are. I'm just going to give you the values. A proton has a mass of 1. Technically, it's 1 AMU. We're just going to use the number 1. AMU stands for atomic mass units. Yeah, scientists were a creative group. Okay, so protons have a mass of 1. Now, neutrons also have a mass of 1. They're almost identical in size to the proton. A little bit different, but that's okay. The electron, though, is the difference. Electron, in reality, its mass is 1/1837th of that of a proton. Now, that pretty much, think about it this way. You were to stand on your bathroom scale and you were to you see your mass, you were to rip out 1 eyelash and then you drop it on the floor. The amount that your weight just changed would be kind of what you would see in terms of an electron. Let me see if I can get rid of this little thing. There we go, sorry. Okay, so pretty much it's meaningless. So in reality, we say the mass of an electron is 0. You would have to have 1,837 of them in one spot to equal the mass of a proton. Not happening. Okay, so hopefully that makes sense. Going to the next one. Now, proton, neutron, electron. Okay, very good. Now, just a summary. And why are we not sorry? Sorry, guys, this is new technology for me. And let's go back over here. Apparently, I hit white ink. Okay, well, this is unique. So with that, I'm going to go ahead and pause here and I'll splice these in.